So let me turn now to Bob Gillmacher, who you may remember started last week with his first segment on 3D printing. And I got to tell you, Bob, I've gotten an awful lot of favorable comments about the presentation you made. And most of the comments come out to say they've never understood it so well the way that you presented it, and thank you for making it understandable to all of us. So we're looking forward to part two tonight.
Well, thanks, Jim. It's nice to hear that people felt that there was something in it for them. Before I start, I'd like to mention, and some of you might already know it, in a couple of weeks in Springfield, Massachusetts, it's the Big E train show, Amherst train show. And I'm going to be working and doing clinics for Scenic Express there. But there's also a fellow by the name of Martin Welberg. And I don't know whether you all know about Martin or not, but Martin is just an outstanding modeler that lives in the Netherlands. And he has kind of revolutionized a lot of the things that we do in scenery, especially with static grass. Martin is going to be there Saturday and Sunday. So if any of the guys that are on this call, or anybody that's watching at all, gets a chance to attend the Springfield show, and that's the last weekend in January, stop by the Scenic Express booth, say hi to me, but really you want to say hi to Martin because he's the guy. So anyway, we're going to talk more about, and I'm going to share my screen here. Okay. Can everybody see my screen?
Yes.
Okay. We're going to do part two of my 3D printing presentation, and it's more tonight about things that you can do. And my goal is to whet your appetite. I know there's some of the guys that are already doing 3D printing, but there might be some folks that are right on the edge thinking about it. And I just wanted to give you an idea of some of the things that you can do with 3D printing. And I was really happy to hear David speak a little bit earlier about how 3D printing might be revolutionizing O-scales. I'm an ON30 modeler, so I feel like I'm in that category. I mentioned last week that there's always things that you need that you never have. And the first things that I started doing when I got into 3D printing was I found out that I can make a lot of these little parts, the washers, the spacers, the bushings. The washers in particular have really come in handy because I'm going to talk about rolling stock in a little bit. And I'm always needing washers to move around the heights of my couplers or the heights of my trucks. And you can see here's just some of the things that I've been able to make with my 3D printers. I also had the good fortune of buying about 5 years ago a Jim Burns table saw. It's a model table saw. It's about 12 by 12 inches. And it's just an outstanding piece of equipment. Jim unfortunately passed away recently, and I don't know whether his products are going to be on sale any longer. But I needed some accessories for that table saw. So I built up here a sliding sled, but then I also had to be able to extend my fence so that I could duplicate things and have longer pieces of wood on there. I do a lot of my own creation of my strip wood, basswood. And so I was able to make these things on my 3D printer. I'm sure that most of us have a lot of tools laying around, and I tried to eliminate the clutter. And here's a couple of holders that I was able to make. This one for some of the bits that go in my power drivers, and then also my miniature and micro screwdrivers. We've had Kevin Hunter on the show before. Kevin puts together a line of product, and these are the touch toggles, and these are the bases that control them. But I do a lot of work for Kevin, and after every one of these boards are made, we have to test them. And we decided to sit down and design some testers that allow us to do it. And being able to print the bodies on these really made the job a lot easier. For people that are scratch building, and I do a lot of scratch building, I was having trouble at the beginning to be able to get my joists and my studs all in the right place. So I decided to design some of these spacers for the different size windows that I would put on my buildings. And also, these are magnet holders, so that once I start building and put these spacers in, I can actually position the studs and hold them in place with these magnets. This is a fairly large board that I built to do that. One of the nice things that I discovered that we can make, and I know Tissue does a great job of putting out windows, but with a little bit of practice, you can make your own windows. And there's a process called parametric modeling in 3D printing. And parametric modeling basically says, if I can define all the dimensions of a particular piece by one particular dimension, and let's say for a window, it might be the opening that the window is going to go in, then once you change that opening size, all the other dimensions change accordingly. So you only have to do this one time, but you can make windows and doors any size, any shape. I saw before we had some windows that had some arch tops. Any of this is possible using the 3D printer. I also do a lot of work with static grass, and I know that you can buy these things. I've got a number of commercially available static grass machines, but I decided I was going to try to make these, and I made a number of these for folks. This is just a piece of regular PVC, and I think I got this from a friend that's in the medical profession. But then to make all of the grids that go with it, the cap that goes on it, and then the actual tail end of this thing where the power supply goes, that was all done on 3D printer. So if you have a tool and you want to make it, easy way to do it. My club, which is the Four County Society of Model Engineers here in Central Maryland, have some specifications as far as how far tracks have to sit back from the fascia and how far in from each end of the module the track has to end. And we were doing this all by hand, and I got to drink some water. Hold on just a minute, guys. Sorry about that. So instead of doing it by ruler every time, we printed up these gauges, and that allows us to position our tracks, again, from the fascia and from the ends very accurately every time. I have a lot of lighting on my layout, and these are just some dwarf signals that I was able to make, and some light globes. But again, all available through 3D printing. And this is what one of these looks like actually on the layout. This throw here does nothing more than covers up a wire that is coming over and coming up from a tortoise. I mount all my tortoises kind of off to the side as compared to in the middle of the rail. And speaking of tortoises, I don't know about you guys, but I found it very difficult to kind of put one of these tortoises up in the bottom underside of my layout and get all the screws lined up. I found that by able to make these larger mounts, and if you have space, it makes it a lot easier to actually mount those tortoises. Also, Rail Crew came out with a under track uncoupler a while back, and that was something else that I thought, well, why not make them? So I basically reverse engineered the Rail Crew device and got a whole bunch of magnets and was able to make these. Now, I made probably around 30 of them. I have yet to install one, but it was a good idea when I got started. Track gauges and wheel pullers, I needed these. Again, I was able to do these on my 3D printers. I always wanted to have a coal mine on my layout, and this is the mine building that I built. But when it came to handling this area here with the sheaves and the gates, I didn't have anything readily available. I found that with a little bit of research, you can pull up the design and actually print these very easily on the 3D printer. And again, I have a couple of these lights hanging off the side of the building, and these are all printed by the 3D. There's a fellow that's been on the show too, and I think it's I know his name is Larry Knapp, and Larry specializes in World War I ON30. And Larry came to me and asked me whether or not we could do some printing for him. So we were able to download a lot of these figures, or Larry did really, from a company called My Mini Factory, and also a couple of these trucks. These are in World War I lorry, and able to print these up for him. Larry has done just an outstanding job of actually painting and weathering these, but you can see what you can do if you have the capability to make it yourself. Speaking of figures, I recently purchased through a company called Model U out of Great Britain, some of these figures and downloaded them. And this is a build plate that I have on one of my resin printers. These are all 1/48 scale. And I can get about 30 figures on a plate. And this had just come off of the printer. I think I took that off yesterday. I washed it off a little bit with alcohol. It hasn't dried thoroughly, but I wanted to give you an idea what that would look like. Now, here are some of the figures that came off of that printer. They still have their supports on them, so these supports have to be taken off. And here's some figures that with the supports entirely off. So if you don't want to spend $5, $6, $10 a piece for your own figures, here's an opportunity to kind of roll your own. Another thing that I've always wanted on my layout was a turntable. And this was my scratch-built turntable. And when I first built it, I was driving it with a 12-inch diameter flywheel underneath the layout, and a stepper motor was butted up against that. The only problem was there was no syncing at all with any of the tracks. So there was no indexing. I had to really nudge it around in order to get it to line up. And every once in a while, it would start to slip. Well, that lasted for a couple of years. And then all of a sudden, I discovered Kevin Hunter again with his touch toggles. And marrying up Kevin's touch toggles, and this is a control panel that controls my turntable, and an Arduino Mega, and this is a special shield that we made in order to take care of connecting all of the controls on the control panel and the stepper driver. Now I can actually index my turntable, and it has a lot of great features, and mainly because of this piece of software which is readily available for nothing called Excel Stepper. So it allows the turntable to start from a position, slowly start, pick up speed so it gets close to the next track, and then slow down again. And then I built in a couple of controls here so I can make it go in either direction, but I can also nudge it. So in case it's off just a little bit, I can nudge it a couple of steps in order to get it lined up. The problem was, how in the world do I make that software work, and what the mechanism? And this is where the 3D printer came in. I replaced that 12-inch flywheel with this gear that is about 200 tooth gear, and that was all 3D printed. The hub that goes into the layout is 3D printed. And then when I first put my stepper motor in there, the table itself acted as a tremendous sounding board, and that's all you heard. So with a little bit of luck and a little bit of work, I was able to insulate that, but all the parts on this are all 3D printed. Again, if you have a problem, this is a solution that 3D printers can help you with. On my printers, I usually have about an 8x8x8 maximum capacity to build. And my first go round with that turntable was I wanted to replace that 12-inch flywheel with a 12-inch gear, which is very, very large. I couldn't do it on one shot. So this is a 4-part, matter of fact, it's about a 6-part 3D printed, very, very large cog that could have worked on the turntable, but it just shows you that you can really build things greater than the capacity of the printer that you have to work with. What really is interesting me most is the ability to make my own rolling stock. A friend came to me and said he had a O-scale car that was longer and narrower than normal, and he could not take the standard ON30 tops off of Bachmann and use them. So he said, can you make something that's longer and narrower? And this was a 2-piece print. I did this on my resin printer. It has some pegs in here in order to match up the 2 pieces, and then a little bit of sanding here and there, a little bit of putty, but it came out pretty good. And again, my thing is rolling stock. So these are just a couple of the cars that we've been able to print using the printer. On these rolling stock, everything except the wheels and the couplers has all been 3D printed. And you can get some pretty fine detail in doing that. I started by using something that I knew. I had a lot of commercially available Bachmann ON30 gear. So I said, why not take it apart and reverse engineer it to see exactly if we could take the measurements and recreate it. These are some of the underbody parts that I was able to print. So you can get some very, very fine detail with these printers. And I think to the extent where if nobody's going to pick that car up and give it really scrutiny. Now, whether or not this could pass a contest, I'm not sure, but it gives you good detail for the car. And here's just some other pictures of the underbody. And these particular ones on the early times, I actually poured some lead weight in wood molds and then put those lead weights underneath here in order to weigh down these bodies a little bit. And this is when I went into production. So I've made many pieces of rolling stock now. And this is one of mine, and this is a commercial. And I'm pretty happy with the results. I went one step further because I wanted a track cleaning car, and I just modified one of those underframes, printed a cylinder here, and it's got a cap on it, and then filled it with basically buckshot to give it some weight, and it does a great job of cleaning my track. This is a box car. It started out with a laser cut interior, but the outside is all, again, 3D printed. Some of my more recent things, and I showed this last time, these are some water tenders that are pulled behind an ON30 Climax. And again, I'll give Steve Sherrill all the credit for kind of pushing me in this direction. This one is a squared off corner. This one has rounded corners. All of them now have trucks on there. And again, all these are 3D printed. Something else that Steve and I had worked on, and these are not, these are much shorter gondolas than you would normally see out on the open market. These are only about 3.5 inches long, about 12 feet in scale. But we put them together with various number of boards in here. And there's also a version, which I don't have a picture of, which has braced sides for the gondolas. Again, the only thing that we had to put on here commercially was the, not the trucks, but the wheel sets and also the couplers. The last thing that I'll show you is my club had a curved module, and we weren't sure exactly what we were going to do with it. And I told one of the guys that we would work with it. And this entire trussel or arch trussel is all 3D printed. It came in many parts. For instance, the arches were one piece. The vertical pieces here were another. This piece here is a third piece. When the interior is also lined with the same type of material here, but in very flexible pieces so we can make that bend. And then the tops are all individual pieces. And then we printed the piers that are here. And then the final product looked like that. We were pretty happy with it. But I've just brought all this up again to whet interest of anybody that's thinking about jumping into the 3D market. One of the nice things is, and I've got a couple of sayings. Number one is that I'll steal a good idea from anybody. And I'll tell you, I've stolen some good ideas from guys on the show already. Number two, there's never a tool or never a job too small not to justify a new tool. And the last one is, if it breaks, I don't care because we can make a new one. And that's what 3D printing has really brought to the table for me. So there's a tremendous opportunity there to make things, to be creative, and to save money. All you have to do is jump in. And with that, I'm going to stop and I'll answer any questions that anybody might have.
Bob, you showed a bunch of figures on your 3D printer.
Yeah.
I assume that you printed those all at once.
Yes. Yeah. Go ahead.
So let's say that it takes you, I don't know how much time it takes, but let's say if you only wanted one figure, it would take you 30 minutes. If you wanted 5 figures on that table, would it take longer than 30 minutes, or can you do more than one in the same period of time if you do them together?
On the resin printers, and that's what that was printed on, that print took about 6 hours. And the reason why it took so long is that I used the highest resolution that I had. And that resolution is like 25 microns or 25 thousandths of a millimeter. So there's many layers, and that's the reason why it took so long. To answer your question is, if I did 1 or I did 30, it all takes 6 hours because it's going up layer by layer. But from my standpoint, it's worth it because you get so much more detail. And
you can do 6 at a time, let's say, and it's still going to take you 6 hours.
Right. I think there was like 35 figures on that plate.
Jim,
Yeah.
the way to think about that is think about it as a movie, right? Normally you have a movie and the pictures are like this. Just
Yeah.
take the movie in your brain and turn it like this. So each frame of the movie is a layer, and it's like that. Each flash is like a flash of a movie, and it just builds up. The filament printers are like toothpaste tubes squeezing out. So one is mechanically dependent, the other is electronically dependent on the speed, how bright that surface is, and how much it congeal that layer as it builds up. So whether you fill the whole plate or you do one little tiny piece, it's how much time it takes to step up is all that matters. So what Bob's doing is he's being really smart, and then he's using the time wisely by filling the plate up.
Gotcha. Gotcha.
Yeah.
Bob, the other thing that crossed my mind,
Mhm.
it seems if I was going to be a manufacturer in the hobby,
Yeah.
I've almost got to try to position myself in such a way that I'm not a competitor for people who have 3D printers, because the people that have 3D printers are going to be able to duplicate much cheaper than any model that I can produce and sell to them.
You're probably right. You're probably right.
Can I present
No.
a different? Can I present a
Go
different
ahead.
alternative before we say probably right? If you go talk to the guys who build kits, they will generally tell you that the cost compared to the price of the materials is a small percentage. I mean, a lot of the cost is instruction. So, Bob, that actually is my question. So you've done some really cool projects there. How do you share those? I mean, are you sharing the 3D printed stuff on Thingiverse? You know, do you have a Thingiverse account and a channel? And then look at something like the turntable. I mean, it strikes me that if there's a way to take 30 pictures, so people who understand a bunch of pictures, not a lot of detail in terms of writing instructions, and then sell it as a package to people, including how you do the board. Because I mean, that's a perennial problem for people: is how do you automate a turntable?
Yeah. Let me address that one. Because I work really closely with Kevin Hunter, and Kevin and I are in the conceptual stage right now with this, is that on my turntable, I actually went and set my first track and then manually stepped around through software to the next track and then the next track, recorded how many steps it took, and then was able to hard code that into my program. And that works fine. The only difficult with that is that now that I want to add more tracks, I got to go back and redo the cycle. Not a big problem.
Right.
The idea that Kevin and I have now is that you move the track or move the turntable to a track, and you push a button, and it records where
Right.
you are.
Right.
then
You make it
move
you make it program. You make it program on the
Right.
track and write a sketch that's not a hard coded sketch, but
Exactly.
is a soft coded sketch. I mean,
Exactly.
I guess the perspective then is, see, think, Jim, this is the really interesting question is, if you become a manufacturer, sorry, got someone with mic on. If you become a manufacturer, basically what you're selling is everything I need to do something. That's what a kit is. Or if I buy a turntable mechanism from ABC company, it's a complete finished thing, and I get all the parts, I put them together, and that's done. What I think 3D printing opens up is this opportunity to eschew the production costs for the intellectual value. In other words, the intellectual value of what you've created, if you look at saying commercially that kit is available for $250, let's say to go out and buy a commercial version from somebody who's built it out of brass would cost $250, $300. You've got the intellectual value for somebody with a 3D printer to make that on their 3D printer for how much? $10? How much 3D printing cost is there in all the 3D printed things for the turntable?
Well, I can't give you a good answer because I never am able to get it right the first time.
But now that you know, no. Bob, now that you know what it is, if I asked you to build me, if I asked you to
Hey guys, I hate to,
Jim, this is really, Jim, let me finish. This is really important because the whole point is, don't think about yourself as being a vendor that sells stuff where you have to sell the physical component with the intellectual value. If you sold that for $100 or $75, all the information how to do it. All of the components as STL files that I can print, the instructions on how you printed them in terms of detail level. So I can buy that from you. And now with $20 of filament, I get an $85, $95 turntable mechanism that would have cost me $300. This is the thing that this allows is it allows you to rethink completely the business model. It's a transformation like the internet was in business, where you always had to go to the hardware store. Now you go directly to the manufacturer. This is the intellectual value of the kit is not in the stuff. It's in the how they were designed and how they go together. And you can sell that without selling any of the stuff, because anybody with a good 3D printer that's a filament printer can print it themselves. So
Right.
think about that business model as being a different business model. I'm sorry, Jim. I thought that was really important to make that point, not
I
for
agree.
everybody.
I agree, and that's the point I was trying to make, but you made it so well. But I hate to do this, but we've got to move on. And that's the purpose, though, of the group that we started. If anybody would like to continue this discussion, you can do it, but you can do it on the group that we set up. So I encourage, it's called New Tracks Modeling. And I hope that if you want to continue this discussion, because I think it's a valuable discussion, I really do. Up until tonight, I had not really thought about the kit manufacturers having to rethink their business plan based on 3D printing. And based on the new AI, I think that may be even more important for everybody to consider if they're going to stay in business long term. So thanks so much, Bob, for doing what you did tonight. I can't thank you enough.
I'll add one quick comment. Because I am not particularly interested in going into business and selling a lot of this stuff, I don't have to worry about what Phil said.
Yeah.
Yeah, I don't. I do it for fun. And I share that with other people that I know that are in the same boat that I am.
Absolutely. Absolutely. Thank you so very much. You have a great time at Springfield, and we'll see you after that to find out about how to do scenery.
Okay, thank you.
Thank you.